To start ATP paper, and keep in mind 90% students lose marks in this paper, not because they don't know physics but because they don't know examiner tricks. Okay, and in this video I will show you exactly how to avoid those mistakes. Okay, so stay connected till the end of the paper so you can get maximum marks in your ATP. So let's start with the question 1. What they're telling us, a student determines the density of a glass ball, and the student, he has done these things. He has poured the water into a measuring cylinder until it is approximately half full. One thing, places the measuring cylinder of water on a top pan balance. Okay, then he records the combined mass m1 of the measuring cylinder and the water, and this is the mass given to you. Okay, this is all the information just to give you the perspective of the experiment. Now describe one technique for using a top pen balance to measure the mass of the measuring cylinder and water to ensure an accurate reading. Okay, so you are measuring the volume of the water and that thing is placed on the top pan. So what we have to tell, describe one technique we're using for the top pan. Okay, so how you can get the mass reading when you place that thing on the top pan, what you have to do, you have to make sure the reading of balance before measuring should be at zero. That thing is called the zero error, right? Should be zero. So you have to check for the zero error. Second, figure shows the water level in the measuring cylinder. Record the volume V1 of the water in the measuring cylinder. Okay, so what we have to do, if you see it's slightly curved here, this is called the meniscus, right? So you have to take the reading from the bottom of meniscus, that exactly at this point. Achha, if you see this point is 80, 81, 82, 83, 84, this is 85, okay, and this is 90. So sorry, this is 90. So this is 91. Okay. So you have to be careful about this thing. 91. Describe two technique that the student uses when measuring the volume of the, now you have to tell the volume of the water and how we are measuring the volume from the measuring cylinder. So there are two techniques that you have to keep in mind. You have to read at eye level. You're going to avoid parallax error, right? Read at eye level to avoid parallax error. The second one is you have to read from bottom of meniscus, bottom of meniscus. Okay, let's move forward. Part B. What they're asking us, the student places 4 glass balls into the water in the measuring cylinder, ensuring no water splash out. Okay, very good. The student records the M2 of the measuring cylinder, water, and 4 glasses. Okay, so this is the mass of cylinder, water, and 4 glasses. 4 glass balls. Okay, so what you have to do, calculate the mass of 1 glass ball. Okay, so first we have to calculate mass of 4 glass balls. I have the total mass with everything, that is M2. It includes the measuring cylinder, water, and the 4 glass balls. And M1 was the mass with cylinder and the water, that is 125.6. So this is M1. So when you do the calculation, M2 is 132.8 and this is 125.6. You will get 7.2. So mass of for one ball, that will be 7.2 divided by 4. So that will give you 1.8. Okay. Moving forward, the student record the volume V2 of the water and 4 glass. It's the same thing. Okay, calculate the volume of 1 glass ball. So what we were having, we having the volume without the glasses, that was V1, and without the balls, and we have a volume when you place the 4 balls into it. So first you have to find the change in volume, that is V2 minus V1. V2 is 94 and V1 was given above, its value is 91. That thing give you 3. So that is a change in volume, and that change is because of the four glass ball that you have placed inside it. So volume of one glass ball, that will be 3 by 4. It will be 0.75. So this is 0.75. Third part, calculate the density of the glass ball. Use your values in 1B and 1B1 and 1B2 and give the units. Use your equation. Okay. Equation is also given. You just have to put the values of masses. Mass and the volume. 1.8 divided by 0.75. So when you do the calculation, you will get 2.4. And units are gram per centimeter cube. Okay. In part C, suggest two improvements that will help a student to determine a more accurate value for the volume of a glass. Okay, how you can get more accurate value? You have placed four glass balls in it. If you increase the number of balls, you can take an average from a large data, right? So you will have more accuracy. You can use more glass balls. One thing. Secondly, you are measuring volume from the measuring cylinder. If you have to improve it, you can improve your apparatus. You can use burette for more precise volume. Okay, so these are the two ways. So we are done with the question 1 of 10 mark. Let's move forward to the question 2. Question 2 is a students investigate the behavior of a spring. Describe two techniques the student uses when measuring the length of the spring to ensure an accurate reading. You may draw a diagram. Okay, this is the diagram given to you. You have to tell two ways how you can increase the accuracy, right? How you can improve the technique. First is you're taking the reading from the scale. So what you have to do, you have to read ruler at eye level. Avoid parallax error, right? Okay, most students ask that is it compulsory to draw the diagram? No, it's not compulsory. They have written clearly you may draw a diagram. It's your choice. If you want to, you can do it. Okay, but you have to label it accurately. The second can be you have to ensure ruler is placed vertically, is vertical and close to the spring. Okay, for accurate reading. Moving forward, second part, using figure 2.2, record the initial length of the spring with no loads. Okay, this is the figure 2.2 that is on the screen. Do not include the loop at the end of the spring in your, okay, this is the loop that you don't have to include. So you just have to measure this part of it. What you will do on the paper, you will take a scale, you will put it here exactly, and you will try to label the value. So if I do this thing, it is at this point. And when I do it for this, I end up at this point. So this is the length of the spring from this point till this point. If I see this point is 36.4, okay, and this point is 38.5. So what you have to do, 38.5 minus 36.4, and when we do the calculation, 38.5 minus 36.4 is 2.1 centimeter. Okay, but they're asking in millimeter, so you have to multiply it with 10, so it will be equals to 21 millimeter. This is your answer. Moving forward, part B, suspended a load of 1 Newton from the spring, records. This is the information what the student have done. He has suspended 1 Newton load, records the length of the spring in table 2.1, calculate the extension of the spring using the equation this. Okay, What the equation is, change in length is original length minus, sorry, change in length is the final length minus original length, and L minus L naught is constant, that is 21. Okay, now what you have to do in at this place here, you have to put all these values one by one and you have to get the answer. Let's suppose if I have to find here, what I will do, it will be 42 minus 21. For this, it will be 61 minus 21. This will be 82 minus 21, 107 minus 21, and this is 125 minus 21. And when I do the calculation, I will get this is 21, this is 40, this is 61, this is 86, and this is 102. Sorry, this is 104. Okay, I'm going to erase this part, so you just need the final values. Okay, in this question, it's a 4-mark question, you have to plot the graph. Okay, first you have to look at how the marking scheme will work. There are 4 marks. Okay, you have to write it down and keep in mind these points so you can get the 4 marks in this question. Mostly students lose mark in this question in ATP. Okay, first mark is for labeling the axis. Like they have told you the y should be load and its units are n, and x should be x, its unit is millimeter. This thing will give you 1 mark. Okay, second mark is for the scaling. Okay, let me draw this table so I can easily check the values and mark them there. Okay, okay, so by the way, this is very easy scaling question. In this, the values are very easy to fit in on it. Achha, in the question, they have given us the table. This should be start from the origin 0 0. So this reading will be 0 and 0. If you start this thing with 0, you have to draw the length. Load is from 1 to 5. So it's very clear that you have to, this should be 1, this should be 2.0, this should be 3.0, this should be 4.0, this should be 5.0. You have to choose a scale in a way that at least you will cover the 70% of this given area. That is the basic criteria that you have to follow. Then you have to plot x, scale x on the x-axis. It's starting from 21 ending at 104. So you have to take the reading from there. 0, this can be 20, this can be 40, this can be 60, it can be 80, it can be 100, and this can be 120. Okay, so with a gap of 20, I am doing this thing. Okay, so the first reading we have is 1 and 21. Okay, at 1. Okay, in on the x-axis, keep in mind on x-axis, 1 box is equals to 2 newtons, and on y-axis, 1 small box is equals to, sorry, this is not newton, this is 2 millimeter. This is 1 newton, 0.1 newton. Okay, that you have to keep in mind. Okay, so at 1 it is 21, so it will be somewhere at between this point. Okay, for 2 it is 40. At 2 it is 40, so it will be exactly at this point. At 3 it is 61. So 3 and 61. 3 is here, 61 will be somehow here. And then there is 486. At 4 it is 86. This is 4 and 86 will be, this is 82, 84, 86. It will go there. And then at 5 it is 104. 5 and 104, this is 102, 104. So this will be a point. Okay, so we have the third mark is for this thing. First mark for the labeling the axis, second is for the scaling, third is for the right coordinate. You have to point out the right coordinates. Now you have to draw the best fit line. Take the scale, draw it like this. The same number of points should be above and below it approximately, and you will try to move this line through maximum number of points. Okay, one thing more, it's a load extension graph. It should pass through the origin line. Okay, it's also passing through the origin line if you see it. Okay, you don't have to force it, but it's passing. So this will be a line. Okay, so this is for the fourth mark. If you do it properly, you will get full marks from this question. In second part, state and explain if your lines show L and X are directly proportional. Yes, it's showing. How we know? We know because you will write yes, it's a straight line passing through origin. So it is directly proportional, obviously. In question 3, this is from the electricity portion. A student investigates circuit containing different combination of resistor, and the circuit is given. And circuit 1 contains one resistor of resistance X. Okay. The student closes the switch and measures the potential difference and current. The voltmeter and ammeter readings are given. It's shown on the diagram. What you have to do. Okay, this is the part 1. You have to record in table 3.1. This is the table 3.1. Okay, let's try to sort this thing. Okay, these 10 divisions are equals to 1. So 10 divisions equals to 1 watt. So 1 division is equals to 0.1 watt. Okay, this is the way to solve this thing. So I have to check, this is the 10, sorry, this is the 2, 2.1, 2.2, 2.3 and 2.4. So this will be 2.4. Okay. And for the current, it is different. It is 10 divisions are equals to 0.2 ampere. So 1 division is equals to 0.02 ampere. Okay. So this is 0.2 and this is at the middle of 0.2 and 0.2. This is 0.3. So this is 0.32. 0.32. Okay. You have to find R. This R relation is given where it is given. It is given here. Okay. R is equals to V over I that you have to use. So R is equals to V over I. V is 2.4. I is 0.32. When you do the calculation, you will get 7.1. Okay. In second part, figure 3.3 shows circuit 2. Circuit 2 is given. Circuit 2 contains 4 identical resistors, each of resistance X. And then again you have the readings and you have to record in the table. Okay. So if you see it's the same thing, it's at 2, this is 2.1, 2.2, this is 2.3. So I will go back. It is, sorry. This is, yes, this is 2.3. This is 2.3. Okay, then this is 0.2. This thing is exactly at the middle. This is 1, 2, 3, 4. This is at the middle. It is 0.3. It is the middle of 0.2 and 0.4. So it is 0.3. So it is 0.3. Okay. So 0.30. Let's calculate this. You have to find the R. R is V over I, 2.3 divided by 0.3. So 2.3 divided by 0.3, it will give you 7.66. You can write it as 7.7. Okay. Let's move forward. In the fourth part, theory suggests that the resistance of the circuit 1 and circuit 2 are the same. And you have to state whether the results support the suggestion, justify your statement by reference to the values given. Okay. What we have values, we have one value is 7.1 and other is 7.7. So I can say yes, they are equal. Why they are equal? They are within range of experimental accuracy. For your knowledge, that range is 10% plus minus 10% for IGCSE. Okay, how you can check? You can take the maximum value minus value minimum, that will give you the range, the difference of the values. Okay, divide by the average value, multiply by 100. If this thing is less than 10, your answer is they can be considered equal. Okay, this is how you can check it. Otherwise you can just estimate, like I'm looking at values 7.1 and 7.7. Okay, I should give the reference of these values because they have asked us in this thing. So how we can, I can write down this thing. Let me rewrite it, or let me make the space here. Okay, I can do it like this. I can say values 7.1 and values 7.1 and 7.7 are within the range of experimental accuracy. Okay, you just have to give the reference of the values. Let's move forward. Question part 5. Figure 3.5 shows a circuit 3. Circuit 3 has this type of circuit. Contain 9 identical resistors, each of resistance X. Predict the resistance of this combination of resistor. But if you see, there you need the knowledge of the circuits. This is X, this is X, this is X. So this whole thing is going to give you 3X. This whole thing is going to give you 3X. This whole thing is going to give you 3X. And this whole thing is in parallel with each other. So it will be 1 by 3x plus 1 by 3x plus 1 by 3x will give you what? 1. Okay, when you solve this thing, sorry, you will get, sorry, it will not give you 1, it will give you 1 by x. That is equals to 1 by r total. So r total is equals to x simply. So it will be same. So answer is X. Part B, another student performed the same experiment but uses a digital ammeter. State the advantage. Okay, in digital ammeter, you don't have to worry about parallax error. So there is no parallax error. Okay. And then you have given the value, you have to write down in ampere. It is 290 milli. Milli is 10 power minus 3. You have to divide this value with 1000. You will get 0.29. Okay, this is your answer. So just two reasons why the switch is open after readings are taken. The switch is open. Why? Because we want to prevent heating of components. If the current will keep on going, the components will be heated up, right? And the second is we are preventing battery drainage. Okay, if you don't switch it off, the battery charging will be low. Okay, so we are done with 3 questions. This is what you can say, it's the most important question, and mostly students lose marks here without realizing what mistake they are doing. Okay, so this is very important. So, and secondly, student mostly ask, sir, can we make the headings, can we write down in paragraph? So there is no hard and fast rule from the Cambridge, but what I will suggest as a examiner and as a trainer for the Cambridge, that I prefer the headings. So when you make the headings, you will not lose any marks. You will be conscious about what you have to put into it. Okay, you can take the pencil and pen. I'm going to say the headings that you have to make, so you can write it down and you will have a format of it. First of all, you have to write down additional apparatus in all the experiment. First heading. Okay, I hope you are done writing additional apparatus. Second, you have to write down independent variable. Independent variable is that you will change. You will change it by your choice. Then there is dependent variable. Dependent variable is the variable that will change because of the independent variable. Okay, so this is the third heading. Okay, write down the fourth heading. Fourth heading will be a method, or you can say procedure. Okay, you have to write down the detail, you have to narrate all the story in it. And in the procedure there are some extra doesn't mean you will get 8 out of 7. Okay, it's mean there is mark allocated for this thing. So when you are writing down the procedure, you have to write down, we will repeat the experiment for the different readings, okay, for the different values, or you can write down any precaution that will give you that allocated extra mark. Then you have to make the heading of table. Then at the last you have to make the heading of conclusion. Okay, I hope you are done writing. Let's solve this question. In this question, a student investigate the rate of cooling of hot water in a container which has a lid. Okay, what you have to do, plan an experiment which enabled the student to investigate the effect of different starting temperatures on the cooling rate. So the experiment is between the different starting temperatures and cooling rate. Okay, so one is the dependent, one is the independent. So this will be an independent variable. You will change this thing, the initial temperature, and this thing depends on this thing. This is the dependent variable. Okay, apparatus is given, you can see on the screen. You have to tell them these following points. Okay, it's the same pattern each and every question. Okay, so let's start answering this thing. First, I'm going to write down the heading. Heading is for the additional apparatus. Okay, you have to be very precise to get the maximum marks. Okay, so additional apparatus is what I need. I need a thermometer. Why? I have to measure the temperature, so thermometer will be required. Then I have to measure the cooling rate, so I need the stopwatch. Okay, these are the two essential apparatus that you need. If you skip any one of them, the examiner will not give you the 1 mark for this additional apparatus. Okay, so you have to write down both of them. Okay, so what I have the independent variable that we are going to change by our own choice, that is initial temperature. Then there is the next heading, that is dependent variable. That will be changed influenced by the independent. So this is the cooling rate in our experiment, or rate of cooling you can say. Then there are some constant variables that you don't change. Constant variables, like what we don't have to change, we have to keep beta volume of water constant. One is volume of water, that is the one variable that must be constant. Then it should be the same container that we will use. Then we will do the experiment in same surroundings or same environmental conditions. Okay, so let's move forward. We have to write down the procedure now. You can make the heading of procedure, or you can write down the method here. Okay, it's your choice. You can write down in bullets, you can write down in paragraph, it does not matter. Okay, so what you have to do, you have to pour fixed volume of hot water into beaker. Okay, try to make small sentences. There is one more common mistake. Student will write one single sentence in 3-4 lines. That will confuse the whole concept. Try to make small sentences. Okay, so pour fixed volume of hot water into the beaker. Okay, then what you will do, you will measure the initial temperature called it theta I of water. Then what you will do, cover the beaker with lid and pass thermometer through it through a small hole inlet. Okay, you have to make a hole in the lid and then you can pass the thermometer into it. Now what you have to do, you have to record the temperature. You can choose a time after 2 minutes, after 1 minute, after 5 minutes. Okay, record temperature after each 1 minute. Okay, so there is a flexibility in the designing the experiment. Like if you don't want to place a lid and make a hole into it, you can change it. Okay, you can place the insulation and you can remove the lid and you can play with this thing. Examiner is very flexible in this thing, that how you are designing the experiment. Okay, because you're not bound in the question that what you have to do. Okay, now we are done with one reading. You have to take multiple readings. Now you have to change your independent variable. So what we will write now, repeat the process same process with different starting temperatures. And what you can do, take, this is for the extra mark, take multiple readings at same initial temperature and find, or you should write and calculate their average. Okay, this is for the accuracy. So we are done with the method. Now what you have to do, you have to make the table. So the next heading will be of table. Table can be, one thing is time. This is the format of the table slash the units. Okay, you don't have to miss the unit of any physical quantity. In table, what is mandatory? The independent variable, the dependent variable, and any reading that you have taken to calculate any one of them, dependent or independent. So there comes the theta 1. You can say it can be the reading, one reading that you have taken. Okay, and units are this. You have taken theta 2 degree Celsius. Okay, same as you can take theta 3. And then you can write down the rate of cooling. That is rate of cooling. So rate of cooling will be degrees Celsius per second. Okay, so this is how you can do it. The last, that is how you will conclude, how you will get the result from all of this. This is, you will plot temperature versus time graph and compare cooling rates. Okay, so this is for your full 7 marks. Okay, I hope you're done writing the format will remain same for all the questions. So you have to fill in these all headings in all the questions. Okay, so question can change, but you have to understand what is the independent variable, what is dependent variable, and what are the constant variables. Then you have to write down the method. In the method you have to tell a story, that how you're going to carry out the experiment. Then there's a table. In table there's a format, you have to write down the physical quantity, but you have to include all the independent dependent variables that you are going to measure, and any data that is used for them, that will also come in the table. And then for the conclusion it will be same all the cases. Okay, good luck.